Hello students, once again welcome to the LJ Institute of Engineering and Technology. Let's start with the course Mathematics 1 and today's chapter, same chapter, partial derivatives, and today's topic is homogeneous function. So what is homogeneous function? First we will understand in this topic, in this lecture, and next coming two lecture is depend on this homogeneous function. So pay more attention. Okay. So let's start with the definition of homogeneous function. An expression of the form a0 x raised to n plus a1 x raised to n minus 1 into y plus a2 x raised to n minus 2 into y square plus up to dash 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 a n y raised to n, in which every term is of nth degree. Here you can see every term is of nth degree. How? So let's have a look. This term, this is first term, and in the term or degree of this term is x raised to n. That means n degree. Now this is second term, and now whenever we are taking the degrees, we have to take x and y both, because we are taking degree of term, and this is entire term. Here a1 is constant, so a1 we will not consider a1, but power of x raised to n minus 1 and power of y raised to 1. So total power n minus 1 plus 1, n minus 1 plus 1 gives n. So this term is also with degree n. Same with this term is also with degree n, because minus 2 plus 2 cancel out, and this term is also with degree n. So in which every term is of degree n, that is called homogeneous function of degree n. Okay, whatever the total degree. For example, if I am taking x square plus 3xy plus 4y square, this is homogeneous function, because each and every term, because your first term contains 2 degree, second term also contains 1 plus 1 2 degree, and third term also 2 degree. So each every term contains same degree 2. This is homogeneous function with degree 2. Okay, this is our only for understand. Now to understand better, let's have a look on the one more definition of homogeneous. We can write this expression, this given expression, in the form this. How this form obtained from this given expression? So if we take x raised to n common from each and every term, then we have remaining terms a0 plus, if we take x raised to n common, so we have x raised to minus 1 and y. So x raised to minus 1 is 1 by x, so we have y by x. So this is y by x. Same way, if we take x raised to n common from this term, we have x raised to minus 2. So y square, and x raised to minus 2 is 1 upon x square. So y square by x square, it means y by x whole square. So on the last term, in last term there is no x. So if we take x raised to n common, so we have to divide this last term y raised to n by x raised to n. So we have y by x whole raised to n. So here you can see this expression becomes of y by x. So we can write this entire bracket is a function of y by x. So we have x raised to n into y by x. So given expression can be written of this form. If you want to take common y raised to n, even though you can write, and this expression will be of the form y raised to n phi of, if we take y raised to n common, then function is of x by y, because we are taking y raised to n common. That's why. So you can do this or this, whatever you want to take common, x raised to n or y raised to n, you can take common, and this n is the degree of the function. So a function f of xy, which can be expressed as x raised to n phi of y by x or y raised to n phi of x by y, is called homogeneous function of degree n, because of this n in x and y, two variable x and y. Okay, so if in examination definition of homogeneous function is asked, then you can write down this definition. Okay, so this is the concept of homogeneous function. Now, to understand better and in example how we will apply this, in example how we will check the given function is homogeneous or not, we will apply this concept. That means a function f of two variables x and y is said to be homogeneous function of degree n by putting x is equal to tx and y is equal to ty. That means the function f of xy becomes t raised to n into f of xy for any real number t. Then this n is the degree of function, and the function is called homogeneous function. We will do this concept for example. And what is the meaning of this? F of xy becomes t raised to n into f of xy. That is f of tx into ty is equal to t raised to n into f of x comma y. Okay, same concept we can apply for three variable x, y and z. Okay, then function of degree n by putting x is equal to tx, y is equal to ty and z is equal to tz. Then function f of x comma y comma z becomes t raised to n of t raised to n into f of x comma y comma z for any real number t. That is f of tx, ty, tz is equal to t raised to n into f of x comma y comma z. For the given function, if we will get this or this for two variable this and for three variable this, then we can say that given function is homogeneous function and degree of the function is this power of t. Okay, whatever the power of t is the degree of function. So now to understand better, let's have a look on the example. First example, examine whether the function u is equal to this is homogeneous. So first we will examine that if this function is homogeneous or not. And if this function homogeneous, whenever we get this form, if u of tx ty is equal to t raised to n into u of x comma y. If we will get this form with any power of t, then we can say that given function is homogeneous. And if this function is homogeneous, then find its degree. And that is the degree, the power of t. Okay, so let's start with the solution. First, we write down the given function u. But to check this method, by this method, we will write this u like u of x comma y. This x comma y, because this u is a function of x and y. Other than this, there is no use of this x comma y. But to check homogeneous, we have to write this because we have to put x by tx and y by ty. So by putting x is equal to tx and y is equal to ty on both the side, we have this tx, ty, this x become tx, this y become ty, so ty whole raised to 2 by 3, same to same in denominator, tx whole raised to 5 by 4, ty whole raised to 5 by 4. We know the rule of indices, whole raised to 2 by 3, that means t raised to 2 by 3, x raised to 2 by 3, similarly t raised to 2 by 3, y raised to 2 by 3, and same concept for denominator. Now here it is clear that we can take t raised to 2 by 3 from numerator and same to same t raised to 5 by 4 from denominator. So we have this step. Now we know the rule of indices. We can take this t together by rule of this x raised to a by x raised to b is equal to x raised to a minus b. This is the rule of indices. Simple, we have already seen in the school level. So we have this step. Okay, this step. So t raised to 2 by 3 minus 5 by 4. By taking LCM, 2 by 3 minus 5 by 4. LCM is 12. So 4 multiplied with this 2. 4 2s are 8 minus 3 multiplied with 5. We have 15. So 8 minus 15 minus 7 by 12. So t raised to minus 7 by 12. And we can see here this is our u of x comma y. So we have this form as we have discussed. U of dx comma dy is equal to t raised to n into u of x comma y. Therefore, u is homogeneous function with degree. This n is equal to minus 7 by 12. So how we can check given function is homogeneous? This is the process. Okay, to understand better, let's have a look on one more example. This is little bit quite different from this previous example. How that you will definitely see by yourself and examine whether the function u is equal to sine inverse of x minus y upon under root x square plus y square is homogeneous. First we will examine, and if yes it is homogeneous, then we will find the degree. So let's start with the solution. As I told, every time we will write this u as u of x comma y, so we can put x by dx and y by dy, and we can see this concept, this format proper. Okay, that's why I am writing this x comma y. And this is the definition for homogeneous function which we are using. So by putting dx and dy in place of x and y, we have this. On right hand side, the x become dx, y become dy, it's x square. So we have t square x square, y square, that is t square y square, as we have seen by rule of indices. Now we can take t common from the numerator. And if we take t square common, and when t square comes out from the root, so it will become a t. So we have this. By cancel out t, we have remaining sine inverse of this. That means sine inverse of x minus y upon under root x square plus y square, which is same as our given function u of x comma y. But where is t? There is no t remaining here. So we can write here 1 into sine inverse of this, and 1 can be written as t raised to n. Okay, so we have this t raised to n, and this is our entire function, given function u of x comma y. So we get this form here. Okay, u of dx comma dy is equal to t raised to what? 0. Yes, and into sine inverse of this, which is our u of xy. So this is same as our definition. So u is homogeneous function, and degree of the function is t raised to this 0. 0 is our degree. So degree is 0. Okay. So here you have seen how this example is different from that. Is quite different that t will cancel out from the function, so we have to use t raised to 0. Okay, now one more example to understand that homogeneous function. We have this example. Examine whether the function u is equal to tan inverse x cube minus y cube upon x plus y is homogeneous, and if yes, then find degree. If no, then we cannot find the degree of function. Okay, so let's start with the same concept, same starting. We will write down this u as a u of x comma y, so we can put the value of x and y in x equal to dx and y is equal to dy. So left hand side we have dx dy. On the right hand side, x cube, that means t cube x cube, y cube, that means t cube y cube, and in denominator dx plus dy. If we take t cube common from the numerator and t common from the denominator, by cancel out this, that means by using the rule of indices, 3 minus 1 power, that means t square. Now here t square is in between tan inverse and this function. So as we have studied in school level, that tan inverse of t square into suppose x, we cannot take this t square out of the function. Okay, so we cannot take this t square out from tan inverse here, we cannot take. So we don't have that definition of homogeneous function. That means u of tx comma ty is not equal to t raised to n of u comma x, u of x comma y. Therefore, u is not a homogeneous function, and if u is not a homogeneous function, then we cannot find the degree. Okay, so how we can check given function homogeneous or not homogeneous? We have seen by three different examples. So you have to make sure that uh, given function, whenever the function is given, you have to just write down this x and y, and by replacing this, you have to go with step by step. You can do some step directly, okay, but I'm just here explaining you basic, so I have just written so many steps, okay, and by this concept you can do more and more example. In this lecture I'm not giving you practice example because this is so easy, and we will use this concept in just next lecture, okay. So you will get there many example how to check homogeneous function, and then we will apply one theorem, and theorem is called Euler's theorem. Okay, so thank you for watching this video. We will see you soon with next lecture, which is based on this homogeneous function. So keep learning and see you soon. Thank you very much.